All right, we're going to go ahead and get started. I want to remind everyone that this is a broadcast and it's being recorded, so you can refer back to it later. Slides will be posted after the broadcast. As part of the recording, I want to remind people that if you do ask questions through the Q&A, those will also be part of the recording. So make sure to ask them appropriately. Speaking of which, the way that you ask questions is there is a Q&A tab on your Zoom interface, like file folder with a little Q in there. So if you do have a question for Robert, then please ask it there, and we will handle it during the Q&A period. We've left 15 to 20 minutes for questions as part of this presentation, so we are happy to have your questions. So let me introduce myself. Those of you who are Kubernetes contributors have seen me before. I wear multiple hats. I am the Kubernetes community manager for Red Hat Linux, where I work on our Kubernetes contributions. I am also currently the release lead for Kubernetes 1.11, which goes into Code Slush today. But today I'm actually wearing my hat as CNCF ambassador. And I'm an ambassador because I started the Portland Kubernetes user group, actually Cloud Native user group. Plus I do other things for CNCF, such as introducing this webinar. It is my tremendous pleasure today to introduce Robert Allen, Senior Director of Engineering from Houghton Mifflin Harcourt, who is going to be presenting to us on using Linkerd service mesh in production. A lot of you have heard a lot about service meshes lately. Linkerd, Istio, Conduit, others are interested in how you can make use of this. Since Houghton Mifflin is already deploying this, or has deployed this, we'll find out. I thought we would all be really intrigued to find out what that experience has been like and what it's done for them. So welcome, Robert.
Thank you. So to answer that first speculation there, yes, we have been in production with Linkerd for maybe 14 months, 15 months approximately. So we've been doing it for pretty much since they got started with it. So Houghton Mifflin Harcourt, who are we? Well, we're a publisher. We were founded in 1886 in Boston. So we've been around for a long time. This brings a lot of organizational challenges, being an old company, trying to remain innovative, new technologies, etc. This won't entirely be just the technical side discussion of getting a service mesh in production and running it in production. I'll also talk about some of the business challenges that go with that, as well as perception and working with other parts of your organization, and in some cases your customers and vendors. We provide instruction to teachers and students, instructional material. We define some of the educational practices through research, as well as provide thought leadership and forums for people that work in the industry. Instructional content, we publish books going way back. Some of them you probably know: Lord of the Rings, The Hobbit, Life of Pi, and several others. In addition to that, we collect data on students' tests, both high-stakes tests, formative tests, summative tests, and we provide reporting and research findings from that information as well. Who am I? Well, currently I'm the Senior Director at Houghton Mifflin Harcourt, but in the past 35 years or so, I've worked as a auto technician, cabinet maker, systems administrator, Windows NT 351 and on, and software engineering for some time. I've been active in open source now for 23 years, going all the way back to contributing to the PHP MySQL and various other PHP applications, since that was my first language some 23 years ago. I lead a team here at Houghton Mifflin Harcourt called the Bedrock Technical Services Group. Our primary goal is to make the Bedrock platform safe for engineers, not engineers safe for the Bedrock platform. That Bedrock platform has over the years, grown. It's been here. I began it when I started working here almost 5 years ago. It began with Mesos, Zookeeper, and Elasticsearch collecting the logs. And as time went on, we needed orchestration. We needed, some form of scheduling that was reliable. And then we needed a way to route to those services. And at the time, Finagle was a great fit. On a side note, Linkerd is actually based on Finagle at its core. Much, if not all, the functionality is Finagle. Linkerd provides a nice abstraction and way to interface those various services, as well as a nice plug-in architecture to write and create your own plugins. As time went by, I met William and Oliver at MesosCon 4 years ago, maybe 3 years ago. It's been so long. And before they actually started Buoyant, and we talked a bit about what we wished we could do with, Finagle, and ultimately, little did I know at the time that it's exactly what Linkerd is today. A year later, one of the guys on my team asked if, have you seen this Linkerd? And started looking at it. It was exactly what we needed. As our services scaled out over time, and the amount of applications that were running in the stack, it became more and more difficult for us to actually provide rapid delivery of infrastructure for the 350 engineers and the approximately 1,000 jobs running in our cluster today. So without the programmatic characteristics that we're able to build into our routing with Linkerd, we would not be able to provide the level of service that we do to 128 million students, 350 engineers, 26 countries today with the 6 people I have on my team. I'm not sure what happened. So one of the things, if you're familiar with Linkerd, you're familiar with DTAPs and or Finagle, delegation tables. And this is really this is the heart of the complexity or simplicity, depending on how well you do this. Generally, those look more like, they can be as simple as 3 or 4 lines. And why is it saving? Sorry, 1 second. Generally, Twitter was very good with, Twitter wrote Finagle, and Twitter has always been, I believe, very good with their delegation tables or DTABs that they use, where you can write 5 lines of DTAB code and pretty much route everything in your arsenal, and do it between a local environment on a laptop all the way through your various stages into production, and without ever changing those 5 lines. And that's really the power of Finagle and by extension Linkerd. Now, as you drill into this, some of these DTABs are very short. So here's a 6-line DTAB that routes a service to the admin port in Mesos for and actually 3 different, well, potentially to infinity when it goes to the discovery announcer. It's able to parse that out into a known pattern. Now this is a much more complex DTAB. These actually go to specific services to prevent any kind of implied or implicit destination routing, and which sort of, as you expose these things out to production with Linkerd, you have to think about some of the security characteristics. And internally, you want to be able to utilize the L5D headers. So there's the context deadline where you can actually, if a request is taking too long, you can deadline that and it will end the request. Or you can have, the context trace where you're actually tracing it, force a trace. Or, if you're making a request through Linkerd to another service and you've already initiated a trace upstream, you can pass that through. You can also put delegation tab snippets, so you can change your routing on the fly. And you can also create, you can also force sampling of a request. That's all well and good on an internal private network. You don't want to do that. You don't want to expose that functionality outside of your network or outside of your control. And so we route all of our requests through HA Proxy to, one, provide the functionality of actually scrubbing these particular headers out on the public side, but it also provides us with, TLS negotiations. All of our requests basically go through a single HA Proxy cluster of X number of servers, and then it's passed off on localhost to Linkerd, which then routes downstream to other Linkerd nodes in the system. There's a whole lot of moving parts involved here, and I've sort of rushed off talking about them all. But it's really just, one step at a time, and understanding how they all fit together. Measurement, we measure a lot of metrics on all the routers. That is a screenshot of our dashboard, but when I go over here to the actual dashboard, so every router in Linkerd is a metric. That is a whole lot of metrics. And since we have 1,000 jobs running, there is an actual measurement for each one of those jobs. Some of them are not busy. Back to school's coming up. We'll see them actually picking up, but and it's end of day in Europe. And some of them are busy, but you're able to get all of these metrics. You can measure your latency, your request volumes, your success rates. We look more for the delta in the success rates. So if we see, spikes in error rates of various 500 errors, that's when we start alerting and take a look. There was a bug in Namerd, which is what provides the logic for the routing in Linkerd. It negotiates the request with Zookeeper. There was a bug that we ran into some months back that after several days, it would just lock up and stop, resolving requests. In those situations, we would, we saw a high peak of 502s, I believe. Anyways, it prompted us to really start watching that much closer. That bug has since been fixed. You shouldn't see it at all anymore. Anyhow. Really blowed through this, didn't it? So some of the things to consider, we have for the last 4 years, we've used Aurora, Apache Aurora, and we use the Zookeeper server sets for our discovery, and that's worked very well. But we're in the process now of actually moving to console for our service discovery, mostly because tasks that are running in a Mesos agent aren't necessarily host aware of what's going on with the actual service health checks, service registrations in console. We can get a much more granular, understanding of the health of a Mesos agent, and you also get the ability to route requests based on the nearest in. Those are some really nice features that come with console service discovery. We expect to have that probably in the next 3 months, have that wrapped up and switching all of our service discovery off of reliance on Zookeeper and onto console. It's not that we're not anti-Zookeeper like you see in a lot of shops. We're actually quite the opposite. We've had very good success with Zookeeper, and it's worked very well. Where we have seen trouble is that there seems to be a bit of a learning curve in general, and with 350 engineers, it's not an easy thing for 6 people to run a cluster and provide outreach, continuing education on working with Zookeeper, proper patterns, etc. Whereas with console, we found that to be a much easier thing for people to pick up on. Some of the other things is we actually enrich the requests that come in with using Linkerd. We built plugins. We call it the Invigilator, which is a fancy name for a proctor, basically. What it does, it actually looks at the request that comes in. It validates a JOT token for service requests. It validates that JOT token and then provides an understanding through header injection of what what claims that particular request store has, and it's able to then basically authenticate and then alter the request downstream based on those details. That is a work in progress. That part of it is perfectly functional today. The things that we're adding to it more and more is being able to allow a customer, a student, a teacher, a school district, etc., to choose to use a specific version of the API or of a UI, and then based on their request we look at the authentication information, what user it is, and then we alter the DTAB to go to specific versions of an application, be it a beta or in the school, in the public school system, or in the school systems in general. They're not very big fans of change. They don't like to see their UIs change or their APIs. They would rather wait 9 months with a broke application or a bug than to have that bug fixed and change something in a lot of cases. And so it makes it very difficult to, you might have 10 customers that want it fixed and 20 that don't. You still want to progress the 10. You need a really good, clean way of having parallel versions. And in some cases, you have people that want to do their testing or such in beta. And so we're actually expanding our plugins with Linkerd to provide that functionality. It works very well. It's a very simple process of writing a plugin, and once you get started and you truly understand the level of things that you can do with that, it totally opens up a whole new world with Linkerd. And it's just a simple jar, basically, that you just deploy on the systems, and it loads up with the config. It's very nice. Quite happy with that. Other than that, I mean, some of the challenges you have is really, especially in a company it's been around so long. adopting a new technology or a new practice has to be done through influence. And that's really simple if you can show, the value. And that's really what we've done. So we've shown the value in being able to using Linkerd. We've shown the value of being able to deploy applications brand new. We have apps that, from concept to production delivery have been done and deployed in as little as 45 minutes. We don't have to make changes to the routing or Akamai or any of these things because of Linkerd, because it is all programmatic. And that there's a huge benefit to that, because in the past, infrastructure would take 6 weeks or 6 months to get a server, and that's just to go to dev, not even production. And then the whole process of actually making layer 5 changes at something like Akamai or any of the other gateway services that are out there, that can take months or weeks, and it's scary because it's very easy to mess those up, especially when you have a paper trail that's 2 weeks long and it's no longer in the engineer's control. There's no simple way of backing those changes out. Now we control everything through a process, of code review, continuous delivery, and we no longer do layer 5 changes outside of the control of the engineers. And that alone has provided far more value than all the other things combined, I think. It's easy to forget how much productivity you gain from making a simple process change like that, because it just becomes part of the day-to-day, existence. But they're compounding. It's like, it's the opposite, of debt. It's compound interest. It pays back daily, and it allows you to do more and more innovative things that move forward. Anyhow, you have to do it through influence. And, once you show that value, it's a big win. On the financial side, we managed to get rid of over 300 AWS load balancers for services with Linkerd and the HA Proxy solution. That is approximately $18 per. So, I don't know what we're talking about. 18, 20, a lot. A lot of money. It adds up. So, roughly 80,000 a year. That's the rough number. Doesn't sound like much, and for some companies, for other companies, that that's a whole new product line, at least for that year. So, anyhow, thank you.
Thank you. And we have our first question. Adam asks, could you go over in more general terms? I mean, I'm going to paraphrase him, because this is what's needed. Can you go over in more general terms what Linkerd does for your infrastructure, and why you adopted it?
So that's a good question, especially given the context of this. So we use Mesos and Aurora to run all the applications in our infrastructure, all new development. And what that means is that we run about 1,000 jobs, and it grows roughly 4% every month. And of those 1,000 jobs, they're shared on resources across 80, AWS instances. The ports change. They just get random ports. They're on a random host, and it changes constantly. So anytime there's a partition in the network, which is frequent in any cloud provider or any network for that matter, those services get moved to new hosts. These things change. So it's constantly changing. That makes it very difficult to actually route and know where to route your requests to those services. So what Linkerd provides provides us with is a way to route all layer 5 requests, which is, above the network layer, above, the actual TCP, but really it's routing it based on the HTTP requests on the host or to the endpoints, the URL of the endpoints. And what it does is it interfaces with Zookeeper. In our case, it could be anything, it could be Kubernetes or any other service that provides discovery information on your services. But in our case, it's Zookeeper using the server sets, as they're called in that realm, which tells it the host and the port of a given service. And there may be a pool of 9 of those instances, and Linkerd will find the least used, and it will route that request to it. If for some reason it fails and it's a retriable error, retriable being a 500, 5XX request, error code that is, it will then try to another host up to whatever you have it configured. And so it routes those requests into our cluster. How's that?
Sounds good to me. So thank you for that background. So second question, do you use HA proxy at the edge for Ingress and Linkerd internally for backend services? Or is it some other split up? And that's from Adil.
Yeah, so we use HA proxy for the actual ingress into the Linkerd. Currently, there's a bit of flux here at the moment. Currently, all service requests also go through HA proxy. So there's an internal HA proxy and an external HA proxy. So if it's customer facing, there's a very different set of rules that are being applied to those requests. Much more scrubbing, much more intense cleaning. Where our goal is to get to where, so currently there is a Linkerd instance running on every Mesos agent, and every service can request to a .local domain, which resolves to 127.0.0.1 to that port, and then Linkerd would then route to the nearest location. That is in flight. We're not there yet. There's a lot of application configuration changes that have to occur for that to see completion, but I expect that we'll get there this year.
Okay, second question. And by the way, let me remind people, please use the Q&A tab for asking questions. If you do ask questions in chat, I will get to them, but I will take the ones from the Q&A tab first. Which the second one from an anonymous attendee is your decision to stop using AWS load balancers in lieu of Linkerd based on cost, or were there other benefits?
Well, it's not primarily driven by cost. Cost was, and this is a great question, the actual reason for it is that there's a limit on the number of load balancers that can be connected to an auto-scaling group. We weren't originally aware of this, and it turns out that it's somewhere around 50. And I'm not even sure it's documented anywhere. We discovered it quite some time back. I don't know, maybe 4 years ago. It was early in our development. We're reusing the resources so much on these servers that we managed to get AWS to expand that to where we're at now. It's like 350 load balancers connected to a single auto-scaling group, but they aren't going to give us any more. And so the only way that we can continue getting the level of efficiency of resource usage is to stop using the ELBs and ALBs. And so everything else has really just been a win from there. We've gotten a lot more visibility and control over the request, and much more flexibility. But it does provide a little bit more work, but it's not terrible.
Thank you. It's interesting. Okay, next question from Sankate, I believe. My apologies if I'm pronouncing your name wrong. This is a two-part question. One is, what are you using for visualization? Was that a custom Grafana dashboard we were seeing? Using
Yeah,
something else?
yeah, that was Grafana. We use InfluxDB to capture the metrics. There is a bit of I won't say it's a bug, but it's less than optimal, and I intend to get a pull request in there for it. But the routers should actually be like labels in the InfluxDB lines. That way you can aggregate or drill into specifics on each of the routers for your metrics. But the way it's captured right now, it actually captures each router as a separate measurement, and it's not very good, clean usage, and it creates a lot of sprawl. But that's something that at some point I'll try to get around to proposing a change for.
Cool. And the second question was, another tooling question is, what are you using for call tracing? The asker mentioned something called Pipkin.
Yeah, so we use Zipkin. We do use Zipkin. We've used it on and off for quite some time. When you've only got a few dozen or 100, 200 services at the operation level, it wasn't like a big deal. But now that we're using Linkerd exclusively over, with HA Proxy over ELBs, we're talking about 1,000 jobs. We really need the understanding of everything. So Zipkin is first-class service on our stack.
Well, thank you for that answer. One more from Eric P. On chat, and again, I'm going to paraphrase a little. You built all this infrastructure with Linkerd. Since Linkerd was released, we've gotten a couple of other service meshes, most notably Istio and Conduit. Have you looked at those other service mesh tools at all? And if so, what were your thoughts?
Briefly looked at them. There hasn't been really any motivation or need to really look for greener grass. And it's really, pragmatism. Linkerd is solving our problems. It has an easy interface for us to work with. And frankly, I've got 2,000 other things that actually need to be built or replaced. So until it's not solving a problem or it's causing a problem, I'm probably not even going to be looking, at least not for a little while. Yeah, my experience with the others to date has been very minimal. Just a brief scan.
Okay.
I think Conduit is, well, I don't think Conduit really fits our pattern at all, since we're strictly, server set Mesos. I think Conduit is Kubernetes focused.
Mm-hmm. Okay, well, thank you. Another question here from Mohammed. Are any of your configurations open sourced? He's particularly interested in looking at the HA Proxy Oxy config that you guys are using.
They are currently not, but that doesn't mean it will remain that way. We are very interested in getting ourselves in a position where we can give more back. Anybody that's ever been in a large organization probably knows that, it's not easy to make that shift from, the closed source walled garden world and, working towards being a much more open organization. There's a lot of steps that go in that. There's the legal steps, the bureaucratic steps, but then there's also, your hygiene steps with your code, with, how you expose that. We are working through those things. but we're certainly, I mean, there's a lot of areas that we can help. So I'm on Twitter and GitHub. You're more than welcome to, you know, if you have questions or anything like that, let me know.
Cool. Okay, next question. Another one from Adil, a follow-up to Adil's earlier question. Seems like you're using a combination of tools for tracing, service discovery, and monitoring. According to the asker, Linkerd now apparently supplies a lot of that functionality integrated with Linkerd. Are you looking at consolidating the various sort of tool sprawl, or are you happier with the current setup?
I'm pretty happy with my current setup, and the reason is Linkerd is just one tool in, you know, a lot of tools that I have, and while there may be a really great solution, you know, and in a lot of cases, all of these services or most of these services that we run do have really good, you know, one-off solutions for you name it. But what I'm more interested in is what can I do and look at the landscape, because ultimately I'm not locked in to anything that we're running. You know, if something provided the, you know, the level of you know, control and second level scheduling that Mesos does, and it provides some benefit or value that, you know, far outweighs what it is today, then I'll replace it. But, and I feel that way about anything in the stack. But ultimately, what I have to have is I have to be able to look at everything as a single, you know, entity and be able to understand it from a distance. I don't want to drill in and have to micromanage, you know, every little nit and detail about every specific service. In fact, I'm principally, I'm very much against that. In fact, if this thing never squawked, and this thing being the entire cluster, I would be just fine with that. But
okay. So another question from another anonymous source. How has Linkerd helped your development cycle, specifically around concurrent deployments and operational benefit to your developer team? You went over some of that in your presentation. Do you have any other comments around that, like for concurrent deployments?
Correct. So some of the benefits that we've seen is that, and some that we have seen, are seeing, and probably will see in the near future. Some of the things we've seen is that, you know, one, a year ago, we didn't have a way to deploy parallel versions, separate versions at the same time of any given application and provide that to the customer. So we're seeing that. Some of the things we're beginning to see is being able to actually do various types of load testing on production systems without actually hitting production systems that are facing the customer. So we're able to run them on the same, you know, systems right next to each other, and then also measure them separately or differently. One of the things that is planned to be built soon is the ability to, you know, deploy a smaller subset of a production system with different settings, JVM settings or Golang settings or whatever, and load test those, but not really load test them, actually run them in production, measure them, how they're performing, and tweak those settings in real time as they're running with, you know, replacing out instances. These are all things that we're able to do very easily and transparently without affecting the customer because of Linkerd and because of, you know, the functionality it gives us with being able to shift loads or request percentages to specific instances, split those, share those, whatever. And so we get a lot of that benefit because of this. And it all goes back to the DTABs. The DTABs are the best thing about Linkerd. They're also the worst thing about the Linkerd.
Okay. Thanks. Okay, so I've got a question from Sankate, which is actually a two-part question. And the second part of the question is related to another question by Eric P. So I'm gonna take the first part of that question first because it's simpler. So first, Sankate asks, are you using SSL TLS for internal service-to-service communication, or is SSL termination happening at Linkerd? Well, actually, it's not necessarily an either or. Is SSL termination happening at Linkerd or at the services?
So we have HA Proxy provides TLS termination based on the host names. And then we have TLS authentication set up between all the Linkerd instances, both the upstream and then the sidecars downstream on the Mesos agents. All communication, in and out and between all the points are TLS. And that's all managed through Vault. So we run Vault. Vault issues the TLS certificates based on the host authentication. And then, we authenticate those requests that way. Really, and the main reason for that is because we are injecting, authentication information into the request with that invigilator. And so we not only have to authenticate the request, we also have to secure the request.
Okay, so let me give you the second part of the question because both Sankati and Eric have very similar requests. So one is Sankati says, in a production environment, how much overhead does Linkerd add, either in resources or in request time? Similarly, Eric asks, Linkerd being Java-based has a very large memory footprint. And how does this affect resource usage in production?
Both very astute questions. On the overhead, we are and continue to iterate our configurations of routers and router setups to improve latencies. Our first iteration of this current setup that we have actually added 40 milliseconds over what we saw in, not for all, but for some requests, added 40 milliseconds to the request over what we saw with raw finagle. We do believe that and have found that this has very much to do with having too complex of a routing scheme, internal routing scheme, where it was basically filtering down through too many routers before it actually got to the service. We've improved that a lot. We still believe that we can, really bring that down. But on average, we see requests somewhere around total, maybe 25 to 32 milliseconds. Oftentimes lower than that, but it depends on what's going on at the time. They've been acceptable now that we made those changes, but you do have to be mindful of that. And plugins that you're utilizing, rewriters, etc., all of those things can very much impact your performance. So you have to really think about it. And this is also a big part of why we have Zipkin in place now, and why we're capturing all of that. As far as the resources, we haven't seen too much issues with it. We do, like the HA Proxy, the Ingress machines, those are all pretty well dedicated just to Linkerd and HA Proxy. And they're fairly substantial instances. I'm trying to remember what they are. I think they're 2XL. Yeah, I don't. They're 2XLs, C4s, I think. I can't remember. It changes a lot, and I've not seen it lately. The Mesos agents, those are really large. Those are massive instances that we're running, and we've not seen an issue with that either. But it's definitely something you have to watch. The one Java thing that you might want to keep in mind, since it is Java-based, is the actual refresh time on on host name resolution will cause you a problem. If you expect Linkerd to resolve a host name and that IP address may change, it won't unless you go in and actually set it in the JVM argument. It won't actually refresh that host name ever again by default. And so you'll either have to restart the service or just do without until you set that JVM setting. That's the only gotcha that we really got out of the JVM side of it.
Okay, well, thank you. And those are all of the open questions we have, so I'm going to supply one of my own to wrap this up. So you've given a bunch of great advice on using Linkerd in production for this. Do you think you could actually summarize it with like a top 3 things to think about if you're looking at it deploying Linkerd as a service mesh for a large organization?
Well, I would assume that first of all, if you're looking to build out a service mesh, you should have already spent a substantial amount of time decomposing your services and understanding, why you need this. At that point, it's really understanding, what fits. Some services are better suited than others. For instance, yeah, you put me on the spot here. I think that's it's really understanding, does Linkerd fit, or do you go down, conduit, or, are you running Mesos? Are you doing static, host name discovery? Are you looking, some of the cases, it works really well. It works really well for us. But we have, if we were using, say Kubernetes or something, we might not be using it. I don't know. I don't really have any great response for that, I guess.
Okay. Okay, well, thank you so much for sharing your experience with us and with the audience. People are, very interested in service meshes, very interested in how they might use them, but not too many organizations, particularly of your size, have gotten to actually deploying stuff. And thank you everyone for attending, particularly thank you to our question askers. We got some really great questions for this that'll really help. Both the slides and the video will be posted later today. Caitlin, where can people find those? Okay.
The link to the recorded events page is in the chat. So just on the CNCF website, and it will also be emailed out later today.
Cool. So if you're interested in seeing more from that or stuff that you missed or sharing it with others, it will be there. And then see everyone at the next CNCF podcast. Thank you.